at Motia, and he'll be speaking about from fragments to unified, why modern backends need a core primitive.
Who am I? So I am a developer relations engineer at Motia, and so Motia is like a core primitive for backend, and it is open source project. And within like last 9 months, we have scaled it to 15,000 GitHub stars, and we are still growing, and a lot of things are happening. So definitely check it out and open to contributions and all. So we will discuss about why backend fragmentation kills productivity. Everyone knows about that. And then one abstraction. So everyone is talking about abstractions today, because if you know about AI agents and what is happening in the world, everyone is trying to figure it out, like how agent execution layers can be implemented. So if you are on Twitter active and all, in the last 3 days, you must have seen like people are talking about MCP is dead. Yeah, it is happening, right? And then I'm criticizing them like, you don't know MCP. Because I was also one of the contributor in MCP apps, which you can see in the whenever you chat with Claude, there is a xCalidraw plugin plugs up, and then there is a lot of MCP apps kind of. So if you seen the recent Claude's update, which has like 3D diagrams and everything pops up, right? So that is MCP apps. So we will talk a lot of things. First, the state of this doesn't show. Yeah. Okay. The state of a backend development today. So yeah, REST API. So if you write a REST API today, how do you write? Like you write it in an Express, Nest.js, and all of this thing, right? And if you want to plug, we will talk about like traditional architecture, right? So then you want to plug the software engineering. So you use the background jobs. Traditionally, background jobs can be written BullMQ, RabbitMQ, and really popular query things, right? And Sidekick for the queues, workers, retry logic, and all this thing. Similarly, workflows. So one of the temporal developer advocate is giving talk there. So temporal is there, ingest is there, a step function is there, SNS and all, right? People use these for workflows. And nowadays, if you know about the AI agents is nothing but workflows only. It's really new term with AI implemented in the workflows. So how? We will also see that. And then event queues is nothing but your Kafka, RabbitMQ use, and then AI agents. So LangChain, CLOUDxAI is like very popular agentic frameworks, right? So now you can see we are using like 1, 2, 3, 4, 5, 6. Hotel is there. So 6 kind of a different frameworks or tools to make your entire software engineering, software architecture. So overall, everything just use the one as one core, 3 core primitives to be specific. So if you know the backend, it is nothing but registers, functions, and workers. So how many people know about the workers? You all use the workers. You must have seen the downtime with Cloudflare and AWS and all, right? So that is nothing but workers. So then, so these are the fundamentals of the backend. So that's why I said like it is boring kind of a talk. So another thing is like functions. So whenever you, so Atul in the last talk discussed like how the cron triggers happens, how the API calls happens in the agent systems when you chat on the Claude and then it triggers something. So that trigger is your backend primitive, and then it registers some functions. That's how the calls happens. So triggers, functions, and your workers. So entire agent is nothing but a worker. Your Claude code is a worker. So that's how the entire backend system is. So how? So 40% of engineering time spent on integration all of these frameworks together, and that's how in big MNCs and small startups, all of them has the different teams which are working on specific task. And if you're a startup, then you do everything on your, and then you have to bear with everyone. So yeah, every new pattern, every backend engineering pattern is your new framework to learn. So real-time streaming, right? So real-time streaming is like one backend pattern. So for that, you need to learn new kind of a technology. Similarly, queues and message queues. For that, you need to learn about like BullMQ and all, right? So, and state management, popular thing, Redis, everyone knows about it. So, and one of the big challenge. So, do you know like inter-process communication, how it works? Like today, if you want to run inter-process communication, yeah, you have to implement it in the same runtimes. Like if it is your code is a TypeScript written, then it will happen in the Node.js. If you are using the Python, then fast API, and your runtime will be your Python UV or something, right? And then similarly for Rust, you have the similar kind of a framework runtimes. So there is nothing where you can write a consumer in Node.js, then your worker in your producer in the, let's say, Rust, and then your consumer in the Python. So like three different language, but in one system, all works together without any convenience. So that's what we are going to present today. So what there were like primitives for everything. So React, popular thing, right? So why React changed everything? Why people are not using PHP? Means people are using PHP, but how people shifted to React? Because it came up with something called as a core primitive, which is component, as you know today. So if you want to write a front end today, everything is just a component. Your buttons, your pages, all of these are component. So that's how the entire front end world changed. So Next.js and this kind of frameworks which you use today, and US government is also using for its government website right now. So everything is built on top of this component. So what if backend also has a primitives? So that's what we discussed, right? And so Motia, the company where I work, and open source project, it introduced the step, which was a core primitive. And it was kind of our validation for the market, how will the primitives will justified. And yeah, means like people showed up and people contributed it, and it is very well-known framework. And that's how we are expanding now with the 3i. So 3i expanded it to function, workers, and triggers, which I explained just now. More flexible, more powerful. And C. So introducing Motia, which is 3i engine kind of a framework. So it is created with 3i engine. So if you come from the CNCF world, so there is a eBPF, if you must have learned. So eBPF is an engine which backs your Cilium, then there is different frameworks are there. So everything is a primitives. So reducing everything to primitive means system interpret, and then use Motia step-based model. So your entire thing is natively your primitive. So APIs can be written as a step. Cron jobs can be written as a step. Event can be written as a step. And then you all this together, if you, so let's say you want to write a queues. So it is just an event. Event is nothing but queue. And then you want to write some AI agents, which can run on automation, which is multiple cron jobs, which is running on your automation. And that's how your N10, right? N10 is a workflow, which is beautiful dashboards and everything. So at the bottom, it is nothing but event-driven system. So yeah, event-driven core, steps, emit, and subscribe to topics. So there is a topic where it will emit and it will subscribe. So that's how your publisher subscriber work, right? And similarly, polyglot native. So you can write in TypeScript, you can write in Python, you can write in Rust. The JavaScript, Ruby will be added soon. It is still in roadmap. Then yeah, built-in observability or Hotel is implemented from the start. And then open source. So everything is open source, self-hosted. You can self-host on anything. And also we provide cloud. So step primitive. So that's what I said. Trigger is nothing but your HTTP request or cron schedule or event. And then subscribe, it listens to specific event topics which you have defined. So like let's say you have defined I want to use the Slack message. Whenever I do the Slack message, something gets sent to your manager. So that is your topic you subscribe to, and every time your cron ticket runs, it publishes your message. So that's all. And your handler is everything. Entire code will be defined in the handler. So that handles your business logic and whatever you define. And then it emits. So that's what we said. So config defines what triggers the step and what it emits. And handler is your business logic. So you can see it here. See. So this is the send message API step. There is a handler and step config. And triggers, you can see. This trigger you can change to anything. HTTP, cron, event. And similarly path. And this is like typical backend code you know already. So handler, where you write business logic and config. Very simple to understand. And that's how entire simple means backend can be written with you. So that was the send message, right? And similarly, this is process measures. So you can see here, there was the enqueues, which is a message.send, and flows. So flows is nothing but like n8n kind of a flow. But enqueue is, you can say, message.send, and similarly here enqueue message.process. So previous one we called here, and that's how context is saved in the state, which is your Redis. Streams, real-time streaming, and then logger. So you don't need any external console.log and all. Many people hate console.log. Sorry if you don't hit, but yeah, many people hate that. So that's why for the hotel visibility and context object visibility, logger is very good thing. You can just assign it as object to hotel, and it will expose everything. So that's how everything. API step, validate, process, notify. This is how your entire workflows can be written as temporal durable execution workflows or AI agentic workflows. Anything can be written like this. No orchestrator. So step declares what they emit and subscribe to, and 3i connects them automatically. How? So that's what we will see here. This we have already talked about, but yeah, auto observability, logs and traces are there by hotel. So you don't need any external Datadog or something. Similarly, atomic deploys. So deploy entire workflows atomically. So entire thing is just a step, right? So let's say you want to deploy it on any self-hosted deployment, Docker, right? So how it runs locally, it will look the same in the deployment, because entire thing is just a step files. It is nothing but your core primitive. And it will handle the states, everything by itself. Similarly, retries and state management, which I showed. So similarly, this is just the UI things, which we will not talk about. And then, yeah, APIs were written in the REST endpoint, then jobs, background jobs, workflows, AI agent. And that's how, like, let's say any traditional mechanism you write in the companies, any Shopify e-commerce dashboard or anything, it starts with APIs, then background jobs, workflows, and at the end it goes to AI agents, right? So yeah, so as I said, Motia was our prototype, the first version of this vision. And as your need grows, let's say you want to write your own AI agent like Cloud Code. So you can write it with 3i. And I have done that already. So if you go to 3i HQ, 3i repo, there is multiple repos. I have written the sandbox with 3i, like similar to Docker sandbox, firecrackers and all, right? Micro VMs and all. Anything you can write with 3i. And it runs on your $10 chip or Raspberry Pi to like multiple GPUs, very big GPUs. So one of the fun experiment I did this weekend. How many of you know the popular thing which is trending to last 2 days? Auto research. Look, yeah. So on Twitter, just search auto research while you go back if you want to stay ahead of the public. So definitely, I would highly recommend, because Andrej Karpathy is the one of the ChatGPT creator, you know, right? Right? So he did very simple thing. It is just a 4 or 5 files. One is a program.md. This is irrelevant to talk, but I just want to tell you because you can explore it. Program.md is where you define your prompt. Entire prompt will be defined in the program.md. Let's say you want to create some system today. And he did only 3 files, which is like train.py, prepare.py, and then third is like validate or something, which defines his loop evaluation, right? So what happens in the train? He has defined the training of the mechanism, how he created his own nano chat kind of a chat GPT, which he uses on his own experiments and all. So within 1 day, that GitHub repo reaches 25K stars. So that's how it is powerful. I'm not joking. So definitely go check it out. So what I did, that work, so he ran it for 2 days on auto research, on his own auto research repo. So that his own repo validated itself, and it keeps optimizing, and from the 78% kind of a thing he created as a evals, it automatically in 2 days running on the GPU, it validated itself, and now it is on the 97% kind of optimization by itself. And that was just a single GPU. So with 3i, what I did, I sat for 1 day, I learned about the architecture, how it works and all, and then I implemented it with 3i, so you can run it on multi GPUs. So that was a single GPU, so this can be run on multi GPUs. So and I have named it as n-auto research. So what happens in this? You can have the Blackwell GPU, and you can have the like NVIDIA G4X and different GPUs, all will run as a simple four agents on itself, and this is your entire agent swarms. They will run, and then they will validate with one OS which you will define. So this, which took 2 days, that can happen in just 4 or 5 minutes. So that's how powerful the 3i engine is, and similarly, that's how the powerful is the auto research. So definitely, I would recommend to learn about this. Yeah, so that's how the 3i engine, which I talked about. Interoperable invocation interface, universal runtime engine. So you register functions in any language, everything just by one WebSocket protocol. So entire thing communicates with WebSocket protocol. So trigger them with HTTP cron events, chase changes. So you can, with Motia previously, you couldn't write the reactive kind of a steps, right? You can't write the API event cron in just a one step. You have to create like different files, right? Which I showed. But now with 3i engine, you can write one step which has your HTTP, it has your cron event, so everything in itself. Similarly, engines can nest as a workers of other engines. So we talked about auto research, right? So multiple GPU, right? So how multiple GPUs were working? So I wrote that Rust engine. So I wrote like the different functions in Python, and all were scaling with the workers written in the different GPUs workers are written in the Rust. So they were calling as an inter-process communication. So this is a really powerful thing, and people are trying it and learning about it. So yeah, AI engines discover and invoke functions as a first-class participant. So function registry, trigger registry, worker registry. So this is a really nice thing to understand for not a 3i, but your, like if you want to explore more about the backend also. So you can see maps function part to handlers, which we saw in that code, and hot swap handlers. So this is, I will just quickly show you the website so you can better understand this. So this is what I'm saying. See this. One protocol, any language. So Python registers a function. This is your Python ML inference. It registers functions. It also has a register worker. So this is the engine, which is your WebSocket protocol, right? And this is the register function. So this registers a function, and Rust also registers a function. This is here, right? Data transform, and this is ML predict. And you can see Node.js is the one who consumes both. So it orchestrates, right? So you have written your own agent swarm, which is very simple to learn, right? And with AI, you can just give this website to AI and ask it to write agent. Cloud can definitely do it. So try it. You have to chat with it multiple times, but yeah, as you can see, simply register functions and trigger them. That's how it is. And yeah, and as you can see, this is the function, this is the trigger, this is the worker, and you can write that in multiple languages and use that in multiple languages. So yeah, this is what we saw now. And here you can see, this is how you write the APIs today. So this is the Express Flask Fast API, right? And with 3i engine, everything is just a 3i. Similarly, let's say you want to write a background jobs, BoolMQ, Celery, and Sidekick. This is the entire thing code you have to read. And with 3i, it is just a register function and triggers. This is really powerful, right? If you have written the backend, you can understand it is like very beautiful. I don't know what engineering has created, but I just love it. And this is the reactive backend. So how many of you know the convex? Okay, no worries. So convex is famous for the, so you must have learned about the OpenClaw, right? OpenClaw uses convex for the reactive backend. So entire database that queries happens in the OpenClaw because of the convex. So this is the convex, as you can see. And if you want to write the convex yourself, then you will write as a WebSocket Redis Postgres. With 3i, you can do that easily. It's just a register function, triggers, so your pub sub is happening, and then you register functions and your message sent. So this is very simple codes, but for like writing your own thing, it will be little complex. But with just a triggers, functions, and workers. Similarly, for the remote invocation function, I guess you have already tried this with the Stripe Lambda and all. Then real-time streaming, state management, cron we saw. So yeah, and hotel and everything is inbuilt. So this is the few things we already saw, and then you can actually create your own AI agent, which I discussed, right? So see, AI agent. Whenever you have you tried writing, creating your own chat GPT or like a system, like small chat bot or something, right? So this is nothing but this. Your register work. Sorry. So register worker logger, and you wrote your own logger. This is the function which can do the agent research, and then a response will be sent as a tool calling. So see, tool use call LM. Call LM can be your OpenAI, chatbot, Cloud Core or something, Cloud Opus 4 or something. Similarly, Rust. So same thing you can write in the polyglot. So one can be like Rust code, one can be Python, one can be TypeScript. So fun thing, right? So I was talking about this demo. I don't know what time it is, but yeah, we can start it. So here you can see this is the Versal Labs JSON render. So what is happening here? It creates a dynamic personalized UIs from prompts. So you can create your own UI with just a prompt. So if I go here, this is the build a feedback form, right? And this is the live website of theirs. If I click here, you will see feedback form is created and that live UI is getting created, right? So I compared this, I rewrite this one with 3i implementation. So there is like very cool findings I will like to show you first. Yeah. So whenever the browser call is happening in that JSON render, everything is happening at the server side. So what it actually happens when you do the server side, it doesn't do the caching, which is very important thing, right? So whenever there is a one call I did, right? One call I did on that JSON render. So if I next time do the same call, it will not have the caching of the same thing. It will start from the scratch. So this is the problem of the scaling. Whenever you scale, you don't have the caching, so you just waste the AI tokens, as well as you also waste like a lot of your CPU and everything. But I guess I solved this. So see, so what I did, I created a Rust worker, and you have the Cloud API. So I'm using Opus 4 for this. So this is the same thing which they are using, and I use the 3i channel streaming and WebSocket, which render. So this time it is happening at the client side, not the server side. So that's what you can see. So each patch is your one component, and I compared this with JSON render, and you can see it just beats it like very fast. Everything is faster because you don't have the that speed of a Rust. This is just a Rust thing. I'm not talking about caching, right? And similarly, SpecForce native worker, which everything is a Rust worker. So this is missing in the JSON render, and so it doesn't have the scaling, right? So with SpecForce, you can do everything. You have the scaling, you have the rate limiter, everything by itself. And I have actually wipe coded this one, but my wipe coding is quite different. So if you want to learn about it, you have to check out what I do on Twitter. I talk about a lot of workflows and which are used by very big MNCs as well today. So yeah. So if I want to show you the demo, if you think I'm bluffing or something, so yeah. So this is the dashboard with 3 metric cards. Yeah, and this waiting for Claude is the API thing. This is not our app. You can see. This is live app, right? Localhost. I'm wasting tokens for this demo. But yeah, you can see entire dashboard is created, and this is the streaming code. And you can also see the streaming. So if I click on dashboard, let's say, no, I can actually show you the same. I don't know what I did previously, but yeah, dashboard we are creating, right? So if I click again, you can see the live streaming, and similarly, streaming the response, right? Very cool. And you can also create, this was just 2D websites, right? What if you can create a 3D sphere? So that also, see, patches it is creating group, camera controls, everything. Your sphere is created. So you now have the 3D everything. So very cool, right? And you can use this code directly. Yeah, this is code. And yeah, so that's how the backend thing works. and I solved the backend thing, but front end is already there. So this uses the 3i.js JSON render, Anthropic's JSON render React, and this has nothing but your components, 3JS components. So yeah, the catalog and everything. So if you want to learn more, you can just check the GitHub repo. I don't know if I shared it somewhere, but this is how it is on the GitHub. Spec Forge. You can click a photo if you want, but yeah, that's it. Okay. And then if we go back to the slides. Oh, sorry. I will just run it. Yeah. So this was the everything, and demo is already done. Yeah. So stop switching the star and start stepping. So yeah. Thank you, everyone.